Hello, everyone. Thanks again for joining me today for another live presentation. Today we're going to talk about Mars, but before we get started, I just wanted to let everyone know that if you want to ask a question at the end, we are going to be doing that through the chat. I received a couple of questions ahead of time too. But if you want to ask a question, make sure that you're logged into YouTube so that you can use the chat function, which is on the right-hand side if you have it in a regular screen. And that would provide me a way to see what your question is at the end. So we're going to have about 45 minutes of the topic, which is curiosity and perseverance. And then I'll answer questions at the end. So if everybody can hear me, hopefully they can, I will get started in just a minute. We'll get a chance for everyone to log in for today. And let me get my first slide ready. Okay. So today we're going to talk about curiosity and perseverance. But first I'd like to start with a little introduction about myself. My name is Jennifer Ayala and I am a Solar System Ambassador. That's a volunteer program with NASA. We provide programming for people throughout the country. There's about 1,000 of us now throughout the country. And it's a program where NASA provides us access to scientists and engineers in various missions that NASA is a part of. And they provide us details about the science and all the different ins and outs of what they do on all of their missions. And a lot of times they provide us with the images that you're going to see here today, and a lot of the details about the science that happens on all of the missions. And if we can't answer a question regarding something that you have here, I can always go back and ask the scientists. So that's one of the great parts of the program, is that we have direct access to people in the missions. And I wanted to let you know that you probably have another solar system ambassador in a town in which you live, because like I said, there's 1,000 of us throughout the country. So if you live in an area outside of Ann Arbor, which is where I'm from, make sure you look up your local solar system ambassador. So today we're going to talk about curiosity and perseverance. And the reason why I picked this topic was because I personally I'm really fascinated by Mars. I have loved Mars for a while, but as you'll see in a little bit here, there's a reason why I have a personal connection with curiosity in particular. So I thought it would be fun to review some of the things that Curiosity has done, along with the new rover, Perseverance. And Perseverance is launching in, hopefully, fingers crossed, 9 days. That is when the launch window starts for Perseverance. And as you can see in this picture, Perseverance and Curiosity are shaped very similarly, but their missions are very different. And that's really what I want you to learn by the end of this, is exactly what the difference between the two rovers is. Because although they're shaped the same, you'll find that they are quite different. So, moving on here. This is some of the most recent missions to Mars, and keep in mind that Mars is a pretty dangerous place to travel to. Only half of the missions succeed that set out to Mars. So we always want to remember that when we're thinking about a mission to Mars. We're not guaranteed success in these missions. These are several of the missions that were successful. There's a couple missing from this graph here, or this picture. But in the back, we have the Mars exploration rovers. You might know them as Spirit and Opportunity. And next is the Phoenix lander, which landed in the polar regions of Mars. Curiosity was the next mission that landed, and that was landed in 2012. It launched in 2011. Recently, we had the InSight lander, and that is currently functioning on the surface of Mars. Phoenix is no longer, and neither is Spirit and Opportunity, but InSight is, and it's measuring earthquakes on Mars and trying to understand the interior of Mars. The ExoMars rover is a mission from ESA, which is the European Space Agency. ExoMars has been delayed, so it's actually not launching in 2020. It's scheduled now for 2022, but it is a current mission that is going to happen, hopefully. And finally, the Mars 2020 rover is Perseverance. So some of these missions go by dual names, which I want to point out. A lot of times people say Mars 2020 rover, and that is what the mission is called. But recently, this mission has gotten a fancier name, I guess, is Perseverance. So you'll hear both names used for the mission that's coming up later this month. So I just want to point that out because I know a lot of people get confused about what it really is. And then in the sky there, you can see some of the satellites that provide support for these missions, whether it's mapping the surface of Mars or providing communication relays for the things that are on the surface of Mars to Earth. So here's a fun picture that I always like to show people when talking about Mars rovers. There is a huge difference in size in some of these, and I think it's fun to see what they look like in comparison to a real person, because on Mars, of course, there isn't a person or astronaut standing next to them. So seeing them on Earth is quite helpful. So the first one, little guy in the front, we really haven't talked about yet. That's the Pathfinder rover. It launched in 1997, and it was really an experimental concept for rovers. It was only designed to last 7 days, and in fact, it lasted about 30 days. And it was just really to test how we could use rovers on the surface of Mars, because there's such a communication delay between Mars, because it's so far away, and Earth. We kind of have to rely on rovers to be a little bit autonomous, meaning we send them information, they do what they're going to do, and then they send it back to us. We're not driving it with a joystick on the surface of Mars. We really have to program these robots to do their experimenting and then report back to us. So this was sort of a proof of concept mission, the little guy in the front there, which is solar powered. On the left, you'll see an example of Spirit and Opportunity. Those are both twin rovers. They both launched at the same time in 2004, and they are solar powered. Now, those rovers were only designed to last 90 days, but they had been real workhorses of the system. They landed in, or maybe they landed in 2004. I always get those two confused. Spirit landed in 2004 and lasted until 2009. Poor Spirit got stuck in a sand dune and wasn't able to get out. So that's what happened to Spirit. And unfortunately, because these rovers are solar powered, that means that if they get covered in dust or if they are not at the right sun angle, they don't have enough power to function, which is also what happened to Opportunity, but it lasted 14 years. So that's something to keep in mind here for Spirit, for Curiosity and Perseverance. These rovers can last a lot longer than their designed mission profile. And then on the right, you'll see an example of Curiosity. Now, Perseverance is the same size, which is about the size of a small SUV, amazingly. They're quite large. And this rover is designed to last about 2 years. Curiosity is already going on 8 years. And they are nuclear powered, which means they don't rely on the sun, but they rely on plutonium or radioactive decay to get their power, which of course is a little more dangerous, but more reliable because you don't have to worry about dust storms and that sort of thing. We'll talk a little more about that in a bit. So here's me. I am standing in front of Curiosity. You might not see it in that picture. I attended the launch of Curiosity in 2011. So it was a few months actually after the last launch of the space shuttle. NASA had a lot of programs at the time for tweet ups. So people that had social media were invited to Kennedy Space Center to see launches of various missions. And we were more or less the eyes and ears on the ground, another form of media, more or less, to show off what NASA was doing at the time. What was really exciting for me is that I got to meet a lot of the engineers that were working on Curiosity, and I got to hear what they were most excited to learn, what they were nervous about, because they were really nervous about the launch. And I basically just loved what I learned, and I wanted to learn more. And it was one of the influencing factors for me to join the Solar System Ambassadors Program, because not only did I want to learn more, but I thought there's so much interesting going on, I wanted to teach others about it. So one of the cool things we got to do, not only talking to the engineers, here is on the left, those are wheels that were on, well, they weren't actually on the rovers, right? But they were prototypes of the wheels. So on the right, that little tiny wheel on the right is Pathfinder's wheel. The wheel in the middle is Spirit and Opportunity's wheel, which is actually quite swirly and fancy. And the wheel on the left is Curiosity's wheel. Now, look at how thin that rubber is around the wheel. That traction is one of the things actually that Curiosity struggled with. So I thought this was an interesting viewpoint so you can see what exactly the wheel looked like. Now, Curiosity has had some trouble because rocks are sharp on Mars, and I'll show a few pictures of it. So they've been puncturing holes in this wheel. So you can see why Perseverance has a new wheel compared to that one. But anyway, me on the right, that was the day before Curiosity launched. That's the closest I've ever been to a rocket that was about to go off into space. Curiosity is actually inside that rocket there on the launch pad. And then the very next day, I got to see it launch. We were at the press site near where a lot of people may have watched space shuttle missions back in the day. It's also near where the countdown clock is, if you know where that is. And on the bottom right, that's us watching the launch. Now, normally in person, I have someone try and pick me and Bill Nye out of the picture. But since I can't have somebody come up and walk up and see, I'll tell you where I am. I am in the red shirt along the fence line there, looking up sort of in awe. And Bill Nye is 2 up for me, hanging off the fence in the tweed jacket and hat. So that was a pretty amazing experience to watch a launch with Bill Nye. He was just as much in awe as everyone else. If you ever get the chance to see a launch, I recommend it because it's pretty amazing. So Curiosity launched that day, and 9 months later, it took 9 months to head to Mars. So it spent that time in an aero shell, which you can see on the top. It's all safely tucked up in there with a heat shield on the bottom. And it has engines that can adjust its trajectory so it gets to Mars. On the bottom left, you can see the parachute that deploys once it enters the atmosphere. And the tricky part of Mars and why a lot of missions fail is because Mars has a very thin atmosphere, but it's just enough that you have to account for it. So it's 1% the density of Earth. So that means that there's enough of an atmosphere that you could burn up your equipment if you don't have a heat shield. So the heat shield is necessary, but you have to have enough ways to slow down the rover or the lander in order to successfully keep your equipment intact. So they used a parachute as the first step, but because they're entering the atmosphere at 7,000 miles an hour, you have to continuously slow it down somehow. So on the right is what's called the sky crane. And I will say that I think that when I met the engineers before launch, this is what they seemed the most nervous about, because this was the first time they had tried something like this on Mars. So you can see the 4 rocket engines, the small rocket engines that are pointed towards the ground of Mars, and that slows down the equipment enough that then they can lower the rover down on these ropes. So these are like metal ropes, and you can see the graphic here. It seems pretty crazy that it was able to do this. And also keep in mind, again, this is autonomous. There's, about a 10 to 11 minute delay in communications from Mars to Earth. So that means that if something went wrong, the engineers wouldn't know about it for 11 minutes. And this rover has to go from 7,000 miles an hour in the atmosphere to about 2 miles an hour in 7 minutes. So they call this sort of the 7 minutes of terror. And Perseverance is going to be doing the same thing. So keep this in mind when we think about the landing. It was a nerve-wracking experience wondering if it survived this landing. And for those that are wondering, the ropes are cut once the rover hits the surface and the sky crane flies away. So it's quite an amazing thing to think that they programmed all of that from Earth to have the rover do it on its own. So the rover landed in Gale Crater, and Gale Crater was selected on Mars because from orbit, and remember those satellites we saw in the picture? Those satellites took pictures of Gale Crater, and they thought they saw evidence of water in Gale Crater. They thought they could see ancient rivers flowing into the crater. From orbit, they saw evidence of clays and sulfates, which on Earth are formed in water. So they thought they would like to investigate this crater. And another interesting thing about it is if you look in the center, see that little hump in the center? That's actually a 3-mile-high mountain in the center of Gale Crater. So the sky crane is sort of needed in some respects because you don't want to land in the middle of that crater, right? You want to land on the edge where it's flat. So they needed something that sent it to the right place in the crater. And you can see the ellipse there in black is where they hoped to land, and they did. So we thought that we knew a little bit about the crater, and we thought that we could investigate whether there had been water on Mars. And I want to bring one of my friends over here for you to see while we look at this here. I have this is a Lego rover I have, and this is actually one that I made myself before they had the Lego ideas set, but I use it as a little demonstrator. So Curiosity has quite a bit of equipment on it. It has 17 cameras on board, some of which are underneath the rover. Some are on its robotic arm, which it can use to take pictures. It has some on its mast as well. So this is its like little head. It also has rock zapping lasers. And if you look at the Curiosity picture on the screen there, the cam, it looks like the rover has an eye. And it actually shoots lasers, so it can vaporize parts of the rock from a distance and analyze the minerals and elements of that rock from a distance. But on the end of the arm, it also has a drill. So it can take samples from the end of the arm by drilling rock, and we're going to see pictures of that in a second. And then it transfers it here. You can like move the arm into the body of the rover. So inside the body of the rover is a chemistry set, and that's called SAM. And SAM analyzes the samples that it uses from the drill. And by heating it up really hot, it can analyze the minerals and all of the chemicals inside the sample to understand what it's made out of. So that's how we understand whether there's chemicals and minerals for life, how we understand whether there's water. So there's a lot of ways in which Curiosity works to do these things. It also has a radiation experiment and a weather station, communications, and a few other things. I don't have time to talk about them all, but it has quite a lot of different equipment on board. And now here is the sample of Mars. So it really does take real drill samples on Mars. It's done about 20. I couldn't figure out exactly how many because it's done a few recently, but about 20 drill samples. And this is the very first one that it ever did. And this is actually quite close to where it landed on Mars. Now, if you look carefully, do you notice something interesting about this? the inside of Mars isn't always red. So we found out that this gray material is actually underneath the surface, and a lot of the material on the surface has been oxidized or been turned red, just like rusting on the surface of Earth. The same thing process is happening on Mars, although a different mechanism occasionally. But this is the interior of Mars, and a lot of these samples is gray, and that was an interesting find. The drill bit there is on the upper left that you can see. Curiosity can only drill about 6 centimeters deep, so we can only understand a certain amount of Mars. A lot of people think, or a lot of scientists think, that we'd probably have to drill a little bit deeper in order to find actual life on Mars. There could be life lurking under the surface that has been damaged by radiation. So one of the things we learned about Curiosity is that Mars has a high level of radiation on the surface, and that's because the atmosphere is so thin. So we know that the solar radiation from the sun sort of damages the surface. So it might kill any evidence of life on the surface. So we might have to drill deeper in order to find it. So what is Curiosity really looking for? Well, we're trying to figure out if it was a habitable place. And we know that based on what we know about Earth. So we know that what we think about a habitable place is that it needs water. It needs key chemical ingredients for life, like phosphorus, sulfurs, or nitrates. And it needs some type of energy. And on Earth, we think of energy that life needs often comes from plants or photosynthesis, but occasionally life can come from chemical metabolism as well, which is what we think probably, if there was life on Mars, probably was that, unless we're missing some sort of ancient plants under the ground. But hey, anything's possible, because we've learned that Mars was a super wet place. And I think that was one of the most amazing discoveries so far by Curiosity. Scientists had sort of hypothesized that it was wet, but I don't think they really understood until Curiosity came up with these results, how wet Mars was. We actually think that Mars was wet for a really long time, which makes us also wonder what happened to Mars. And if Mars was so wet and had an active hydrologic cycle with clouds and rain, and just think about it as we think of Earth with the puffy clouds and rain that fill the rivers and streams and bring it into ponds and lakes and possibly even oceans. What happened to Mars? Why did it get so dry? And could the same thing happen to Earth? And that is one of the main questions that Curiosity is trying to answer, and Perseverance will be answering as well to some degree. So what happened, and how do we know that Mars was so wet? Because this is what we think Gale Crater used to look like at one point. A long period of time with a lake on Mars with rivers flowing into it. Well, this looks complicated, but it really isn't. Just think of a lake on Earth, and you think of all the sediment that falls out of a lake. And over time, it builds up into different layers. And all those layers settle at the bottom of the lake. And when the lake dries up, you can see all the layers. So think of like rock cliffs on the side of the street. When you cut out a road, you can see all those different layers of sediment. The same thing happens at the bottom of a lake. So what we think happened is that when Mars dried up, the wind might have sculpted this 3-mile-high mountain in the center of Gale Crater. So what does that look like now? Well, check out these views from Mars. This is an actual picture taken from Curiosity on Mars. You can see all of those layers. See all those flat layers in the rock? This reminds me of something that you might see in the southwestern United States with all of this sandstone. This is actually sandstone made in layers on Mars, but of course all the water is gone now. So this is something, these are called Murray Buttes is what the feature was called. And they were found at the lower regions of that 3-mile high Mount Sharp. And Curiosity has found these sorts of things periodically. This is a more recent picture of where Curiosity is. This picture was taken actually in July of last year, so this is about a year old. But this is a close-up view of a boulder it found lying around where you can see those layers again. Another thing, if you're a geologist, you'll notice that there's some white minerals that sort of snake in and out of all that sediment. And that's because we think that after Mars dried up, there was still some water that penetrated those rocks and left behind minerals. So there's so many mysteries that we don't really understand about what happened to Mars and how it was so wet. Well, we know that it had some point in which it dried up because every picture we have now is dry features. But these are some interesting other things that Curiosity found. I suspect Perseverance is going to take some similar pictures because its cameras are even better. So here's a picture on the upper left of an eclipse on Mars. So this is one of the moons, Phobos, moving in front of the sun. The eclipse itself was only about 35 seconds long, so this is sped up a little bit. On the right, you can see high-level clouds in the atmosphere. So these are just icy, type like cirrus clouds, except probably even higher in the atmosphere. So Curiosity and other rovers have seen these clouds in the atmosphere, which is really interesting to me that it still is able to maintain clouds. But you can see these clouds are not going to be producing any rain. On the bottom is dust devils. So they also have spotted dust devils frequently on Mars. So Curiosity and Perseverance and Spirit and Opportunity will probably all see dust devils. I think that is one of the most common phenomenon that they see. This is a selfie of Curiosity. I hope that Perseverance takes some of these as well. I want to show you how this is taken because a lot of people wonder how in the world does a rover take a selfie? And the way that it does that is it points its robotic arm in front of it and it takes a series of photographs in front of it. And then all those photographs are then sent to Earth and the scientists piece them together to come up with this selfie. So this selfie actually the rover took 57 images to take this selfie. You can see how the rover is now covered in a lot of that red Martian dust. It's no longer white. You can also see, I'll make it bigger here, you can see that there's some drill holes in front of it. Now see, not every drill hole shows that interior being gray. So this is in the clay unit of Mars, where they knew that there was probably clay-bearing minerals, which again is something that you find if it's wet. Now look carefully in this picture. If you look in the far distance, you can see the rim of the crater. That's sort of the edge of the crater that Curiosity is in. And on the far upper right, you can see that 3-mile high mountain or Mount Sharp in the distance. So Curiosity takes these selfies periodically. Also, this is a good opportunity to see the wheel holes that Curiosity has found. You can see there's sharp rocks. Curiosity drives slow and carefully, but it's still getting damage from those rocks. You can see some of the holes there in the wheels. So where is Curiosity going? And where has it been? It started in that flat area where it landed in Yellowknife Bay. It took about 2 years to get to the foothills of that Mount Sharp. And there's that Murray Buttes that we saw the picture of, those layered sandstone. It was sort of at the lowest levels of the mountain. And it's climbing steadily up the mountain. And right now it's moving from the clay unit to the sulfate unit. So you can see it's pretty high here on Mount Sharp. And I'll show you a picture of what that looks like. This is sort of the last panorama that the rover has taken. You can see now, we can actually see the top of this 3-mile high mountain, Mount Sharp. That's the sulfate unit is sort of the last destination of Curiosity. I suspect that they will find other jobs for Curiosity to do after it investigates the sulfate unit. It has to navigate a lot of terrain here to get to that point. So if you follow Curiosity this summer, it is going on a summer road trip, is what they're calling it, to the sulfate unit. So follow along with what Curiosity is doing. But keep in mind, Curiosity is pretty slow, and so will Perseverance. It can only go for about 82 to about 300 feet per hour. So they're pretty slow. But it's slow and steady, and they have to be, of course, careful. They plan out all of the missions the night before, and then it carries them out during the day and reports back. So if you're interested in Curiosity, that's pretty much the summary of what Curiosity's been up to. But I want to show you the potential of what a rover is capable of, because understanding a rover is interesting and learning about the equipment's interesting, but if you don't really understand like what it's capable of or what it can show you, it kind of loses some of the interest, I think. So Perseverance is the rover that is launching at the end of the month. And you look at it and you think it really does look quite similar to Curiosity, right? It's got the same body, and that's because it's using some spare parts from Curiosity and the same body design. But as you've noticed, it has different wheels and different experiments. Some things are the same. It has a robotic arm. It has that X-ray spectroscopy, that's really hard to say, on the end of the arm, as well as cameras. Perseverance has better cameras and more cameras. It has 19 cameras on the body of the rover, and it has 4 cameras on the entry, descent, and landing. So I'll show you that in a second, what that means. But it's a total of 23 cameras on this little rover. Well, I guess it's not so little. It's the size of a car. But you get the idea. That's a lot of media to be sending back to Earth. It has a weather station. It has a rock zapping laser again in the eye. It has panoramic cameras. It has a subsurface radar where it can scan underneath to see some of the surfaces right below the rover. And it also has a few things we're going to talk about here in a second, because I want to go a little more in depth on those. But some of the main differences is new wheels. I talked about how Curiosity struggled with its wheels. Keep in mind that even if the tread completely wore off of Curiosity's wheels, it could still perform, it could still move, just a little bit more carefully and slower. But we're trying new designs here with thicker, better traction. They're thinner, but they're wider. Hopefully the newly designed wheels will perform well. One of the things that I'm most excited about, and this kind of seems silly, but I personally think it's very fascinating, is hearing what Mars sounds like. This is the first time we're sending a microphone to Mars. I really want to know what Mars sounds like. So we're going to hear what it sounds like to land on Mars. We're going to hear what it sounds like to drive and perform experiments on Mars. And we're just going to hear what Mars sounds like when it's quiet. So I am really curious what Mars is like when the rover isn't functioning. Is it loud? Do we hear wind? Can we hear those dust devils? So I am interested in that. The main mission of Perseverance, though, is to collect rocks. So it's going to take the drill, and instead of performing a small hole to put the sample inside to analyze, we're actually collecting a core sample of rock that we find interesting, putting it in a hermetically sealed test tube, collecting all of the samples in the body of the rover, and then we'll leave them behind once we've collected them all for a future mission. So that's generally the idea, is that the rover is going to spend most of its time looking for what it thinks could potentially contain samples of life or interesting rock samples, and those are the ones that it's planning on taking samples of. The other thing is an experiment to try and create oxygen, and they say out of thin air, but it's really out of carbon dioxide. But this is a very intensive experiment. So one of the engineers told me that this experiment, which is called MOXIE, by the way, because I'm sure you're going to hear about it if you watch the launch coverage. MOXIE is going to take it just a few grams of carbon dioxide into oxygen, and that is going to require the equipment to be heated up to 800 degrees C. So that is super hot. Think about how much energy that takes. The rover really won't be able to perform any other experiments while the MOXIE equipment is being used, because the energy source that it uses, like I said, is radioactive decay, which is plutonium. And that only produces the power of equivalent to about 2 laptop batteries, or laptops in general. And it has to create the energy overnight, and then it stores it in batteries. So once the battery is used for the day, it has to create more energy into the batteries, and so on and so forth. So it probably won't be doing any other experiments when MOXIE is running. So we want to see if, like, proof of concept, is this possible to do this when astronauts are on the surface of Mars? Are we going to be able to create oxygen for them? And that's one of the things we want to figure out. So Perseverance is packed up and ready to go to Mars. I thought these were cool pictures of how the rover is actually tucked up in that aeroshell on its way before it's tucked into the rocket itself. So this is Perseverance. This is an actual picture of Perseverance with the sky crane above it. You can't actually see it in the aeroshell, but it is on top of the rover in this picture. Notice this black box too. We'll talk about what's in that black box in a minute. So the heat shield is on the bottom in gold, and it's all attached together and then put into, on the right is the fairings. So those are the fairings that cover it during launch for protection. You can also see the acoustic panels, which are in blue, and that prevents some of the sound generation from the rocket from damaging the rover. One thing to keep in mind, the rover is all packed up, but that plutonium is not in the rover yet because it's so dangerous. NASA takes a lot of precautions, and it is not installed in the rover until the very last minute. And I remember from the launch, they take it very seriously. They have quite a lot of precautions. You have to spend, you can't be close to the rocket just in case something were to happen during launch. So yeah, so they take a lot of precautions because plutonium's very dangerous. It's a very reliable power generation, but it is a very dangerous one as well. So they don't put it in until the very last minute. So here are the fairings closed. The rocket is being assembled. I believe the rover is already on top of the rocket, just waiting for launch. They're currently checking out the rocket to make sure that it is safe for launch. There's been several delays in the launch already because of the rocket. They've had some things not quite check out how they wanted. So they had to extend the launch window a little bit, but right now it's currently all set to go on July 30th. So that's only in 9 days, believe it or not. I've been thinking about this mission since they announced it in 2012. So 2012, that was after Curiosity landed. Perseverance, or at the time Mars 2020, was envisioned. The landing site, however, was recently decided in 2018. There were several candidates for the landing on Mars. They designed, built, and tested the rover. They had to wait, of course, for all the equipment and all of the experiments. A lot of them are designed in other countries to be sent and assembled. The launch, we're hoping for July 30th, but the window goes till August 15th. And then it's about a 7-month cruise to Mars, and it lands. Now, this is the amazing part to me. It lands on February 18th at 3:30. That is so precise. Like, they can determine when it's going to land regardless of when it launches. And well, not, I mean, there is a window, but February 18th, 3:30, mark it on your calendar. And then, of course, surface operations. We saw how lengthy that can be for Curiosity, hopefully several years. So we know that it's going to be about a 2-year mission is what it's designed for, but Curiosity showed it can go a lot longer than that. We already talked about Sky Crane, but it's going to perform the same maneuver, the 7 minutes of terror again. And keep in mind, it's about 10.5 minutes is the delay in February between the time in which something happens on Mars and the time in which we hear about it on Earth. And you also have to wait. They usually send like at least one picture early on, and we have to wait until that picture arrives and is sent through the relay system of a satellite. So a lot of times things don't happen right away. You have to wait a little bit to see. It's not instant gratification. So it'll be that 7,000 miles per hour to 2 miles per hour in 7 minutes. I'm pretty excited to see it be successful again. Hopefully, fingers crossed. So one of the new things, though, is that it has a more precise landing. So the engineers are going to take photos on the way down, and then they're going to compare them with a map that is loaded inside the rover. So the rover basically has Google Maps inside, not Google, but equivalent, where it's mapped out all these different locations. And the rover is able to navigate and change where it's going and divert, if necessary, around different objects. So if it sees something that it wasn't expecting, it can divert itself away from it. So I think that is going to be an amazing ability, so we can land very precisely where we want to. It'll have several cameras on board. It's going to be taking videos and images, looking up at the parachute down below at the landing. We've never actually seen the Sky Crane. We didn't have video of it, so we're going to see video of it landing. We're going to be looking up and down at the Sky Crane. So and again, it takes a while for all this high definition video to come back to Earth, but I'm really looking forward to seeing what it looks like to land on Mars. All of the rovers and landers are in this picture. All the rovers land on the equatorial region of Mars. So you can see in reference where Perseverance is going to be in relation to Curiosity. So they won't be able to see each other. A lot of people ask that. No, they're pretty far apart on Mars. They won't be able to see each other, but they land on the equatorial region because it's more temperate. And we hope to have the rovers last a long time, so we try and get them as much ability to do so as possible. The extremes on Mars are quite severe. It can get to a pretty temperate, about 20 degrees Fahrenheit or so on the surface, but it also can be a minus 120 at the equator. So we want to give the rover as much possibility to survive as we can by putting it in the equatorial region. And this is where Perseverance is landing. This is the crater, and you can see how it doesn't have that 3-mile high mountain in the center, but we think from the satellite images, it also had water entering it. So again, we think that this might be the place where we could find life, because we think water has been available in this location. If you look where the circle is, that's where Perseverance is hoping to land. You can also see that structure on the upper left, and we think that is what was a river delta. And here's what they look like on Earth. That's where a river deposits all of its material at the end of its journey. And we think that that is the possibility where microbial life could live. So we're hoping to find it there. And of course, that's what type of sample we're hoping to bring back. So this is an interesting picture of the inside of the rover. You don't see this very often. This is all of the cables and equipment inside the rover. Those that are interested in cable management might be in awe of all of the cables and how neatly they're stored inside this rover. So this is the brains of the operation and all of the equipment that runs the arms and experiments and cameras. In the back, you can see the MOXIE equipment. So that's the one that turns carbon dioxide into oxygen. So I think that is interesting because you don't normally see that when it was open. They took a cool picture of it. This is the sample caching equipment. So you can see they're all covered up in suits to protect the environment. So we don't want to bring our germs to Mars. We're trying to protect the sample equipment the best we can so that if we find evidence of life, we know that it's Mars life and not us. It's not human life, so to speak. So this is what the sample caching looks like, the storage equipment. I have a short video to show you so that you can see in better explanation than I could exactly what the system looks like.
In terms of robots that go into space, the sampling and caching system on the Mars 2020 mission is the most complicated, most sophisticated thing that we know how to build. This is a system that allows us to take core samples of rocky material on the surface of Mars, carefully seal them in very sterile, clean vessels for eventual return to Earth. We've been working on the sampling and caching system for 7 years, and that's because it's a tough job.
We're testing the equipment to make sure that it's going to work when we get to Mars. It has to function on its own. We have to think of all eventual possibilities and try them here first. And then if they don't work, change it now because we can't make any changes later.
To drill into the rock on Mars, pull out intact core samples, seal them hermetically, and to be all done autonomously by a robot hanging off the end of a rover on the surface of Mars has been a challenge. We've got actually 3 robots necessary to do the sample and caching system. Our big robotic arm out on the front of the rover, that takes our drill, pushes it against the surface, and allows us to take core samples. Then we put that core sample in the bit carousel, the second robot that takes that from the robot arm and puts it down inside our adaptive caching system. This is the part of the sample and caching system inside the rover. We've got a little tiny robot, a special robot arm called the SHAW, the sample handling arm. It takes the samples out of the bit carousel and moves them through volume assessment, image taking, and eventually to sealing, and then replaces the cylinder containing the sample in a storage spot, all on its own in the matter of a few hours. We have designs on bringing them back in a decade. Mars has been at the fore of our consciousness about the questions of life. Could life exist in one of our nearest neighbors? I think we have a lot to learn, life or no life, about the evolution of our solar system, about our planet, by looking in depth at rocks brought back from Mars.
So some have asked, what did it look like if we found something that might be life on Mars? It's probably not the green alien that you think of. If it was microbial life, it might look like something like this. This is a stromatolite that is found on Earth. And what we know is that we're looking for not only the important elements and minerals that could contain life, because that's one step, but also visually understanding if it might look like something that we could identify from Earth as potential life. So that's not so easy to do. We don't know if it'll look anything like what we know on Earth, but we'll also use visual inspection to try and determine whether we're going to take a sample somewhere on Mars. So it probably is a learning experience to understand exactly what type of samples we want to take in that delta area on Mars. So I guess stay tuned, because I don't know either what it's going to look like. But I thought it was interesting to show you the kind of thing maybe that they are looking for. So one of the last things I'm going to talk about here is about Perseverance is the helicopter. This is a proof of concept. This is the Ingenuity helicopter. That was what was in the black box underneath the rover. It is actually attached to the bottom. It's about 4 pounds in weight. It's considered to be a tech demo, so it doesn't have any official experiments on board. It's just to see if we're able to fly in the lower density atmosphere of Mars. So it has about 4-foot long carbon fiber blades, and I'm going to show you a little video here that we can watch together. So the rover is actually going to drop the helicopter and drive away so that it's a safe distance away where it can observe the helicopter from a distance. And the helicopter will have cameras on board, so it's going to be able to take pictures of what it sees. So the objective is to take images out ahead of the rover. So since we know the rovers move so slowly, we would like to see what's ahead of us, like in vistas or over the cliffs. So this is what we're hoping. So you can see it also is solar powered. So it's going to fly autonomously, and the rover is going to take pictures, as well as the helicopter take pictures at the same time. So I think that's going to be pretty fun. So this helicopter is going to take multiple flights in a 30-day period. And it's going to be able to stay elevated for about 90 seconds at a time. So see how much better of a view it can get from a height. So all these images will be sent back and we will examine them. I don't know that they're going to make necessarily navigation decisions based on these, because again, this is a tech demo, but we want to understand if this is something we can use on future missions. Also, if this is something that astronauts could use. So most of the things that we learn from these missions is something that we hope to apply to not only understanding the history of Mars, but if it's something that we can help use if we're going to explore ourselves. So I'm excited about that. I hope it works out. So the mission itself is currently set to launch July 30th. That's in 9 days. The launch window starts at 7:50 a.m. Eastern Daylight Time. The launch windows are 2 hours long every day. If it's pushed back, unfortunately, the mission, the time frame gets earlier in the day, which makes me sad because I am not an early riser. But it does get earlier if we have to push it further, and it goes till August 15th. But if we don't make the August 15th deadline, I don't know if they're able to push it out any further. If they miss the window, we need to wait 26 months until the line up of Earth and Mars is optimal. So I'm really crossing my fingers that the rocket's ready and that weather cooperates, because I don't want to wait 26 more months. So here are some resources for you if you're interested. I don't have them on my website yet, but I will have them later today. So if you're interested, all of these will be on my website at wixgirl.com. You can see all of these things are available. The Mars General Mission page is the first one, just for all Mars missions. So the specific to Curiosity and Perseverance is 2 and 3. The press kit, because there is no in-person event happening, there is an online press kit where if you want to read all the nitty-gritty, double check what I said in facts. If you're really super nerdy and want to know all the details, the press kit is the place to go for Perseverance. If you want to follow the mission on social media, it has a Twitter and a Facebook page at NASA Persevere on both. There's a virtual countdown on NASA social. So here's what happened. A long time ago, it used to be called a tweet up. Now they're called NASA socials. So the event that I attended, Curiosity in person, was a tweet up, and they're called socials now. They're not having one in person, so they're having one virtually. If you'd like to join that and see behind the scenes footage, join this virtual social. I recommend it if you really want to see more detail before the launch. If you got kids and you want to do some more Mars games and activities, that's number 7. And want to know about human space travel, that's on 8. And if you want to be ambitious, which I plan to do later, create a 3D virtual model of Perseverance and move it around and check it out. That is the last link. So I have a couple of questions that were sent to me, and I also had one in the chat that I see. If there's any other questions, now would be an excellent time to send them. The first question I see is from Tom, and he said, curious on my thoughts on power sources. Yeah, so Perseverance and Curiosity are using the radioactive decay, which is the RTG. Let me see if I can find this is actually, just pause here, is a good sample here. So on the back, for those that don't know, on the back of the rover here, this is the power supply on the back, and you can see it, a good picture here in this still image. That is where the nuclear sample or the plutonium sample is located, on the very butt, I guess, of the rover. And it is considered to be a more reliable power source because the rover can perform activities when there's no sun. So when there's no solar generation happening, which obviously solar panels would rely on, the rover can still perform functions. And one of the reasons why this was selected was because they realized that the weakness of the previous rovers that relied on solar power was that it's really dusty on Mars, and the dust would coat all of the solar panels. So when all of the solar panels were covered in dust, power generation started to fail. So that meant that it couldn't do all of the experiments over time as more and more dust layers started building up on top. And there was no windshield wiper to blow it off. Fortunately for Opportunity and Spirit, dust devils oftentimes blew off the dust. So that's why they lasted so long, is because the dust kept getting removed. But there's no guarantee that's going to happen. So that's why they usually try and use the plutonium. However, that's in limited supply at the moment. So it isn't as though we can use that maybe for lots of other missions. I don't even know how many more samples of it that we have. So there's negatives as well, not to mention the fact that it's slightly dangerous to handle. But we can use it in situations in which there's dust storms on Mars at nighttime. It's a continuous power source for the most part. It does degenerate over time, of course, because that's how it creates power. But overall, it's more reliable. The Voyager missions used it, and the Voyager missions that are now exiting our solar system are still reporting back. So that's why it's used. Some of the other questions I got were, Do astronauts come and get the samples? No, that's not what we're thinking. We're thinking that in a few years, a mission is going to come retrieve the samples. So a robot is going to come pick up the samples and then put in a sample return vehicle, and then it's going to return to some probably desert region of the United States for analysis by humans, because although the rovers are great, they don't have the same type of equipment on board that we do on Earth. So we can perform better analysis on Earth on the samples to determine whether they are life in them. So the idea is that some type of robotic, I don't know what it's going to look like yet, but some type of robot is going to bring back the samples on a later mission. Could the rover, another question, could the rover take pictures of comets or other celestial phenomena? Well, they have tried this in the past, and the rover can actually see Earth and its moon from Mars. The current comet Neowise, which by the way is still in the sky, if you want to see it in the nighttime sky around an hour after sunset in the northwest, just plugging that for our northern latitude friends. It might, but this comet is pretty dim. So by the time it gets to Mars, it might be too dim for the rover to see. But it has tried other celestial phenomenon, so it is possible that they might try. I have not heard yet, though. And the last question I got is, do you collect space Legos? And the answer is yes. I already showed you my Curiosity here that we made way before the Lego Ideas one. I used someone's pattern for that. I believe it was actually the pattern for the person that submitted it. I also have in the back here, let me reach. I also have an older version of Spirit and Opportunity. So this is, and of course, anytime there's a space Lego, I'm all about that. So if there's no other questions, I don't see any more. I think I'm over the hour. So if you have any other questions, feel free to email me. If you're watching this on replay, I'm always available for questions. We have another question, so hold on. From the perspective of human exploration, what sorts of radiations? Yes. Okay, so let me get a drink of water here. So one of the things that Curiosity found is that there's a large amount of radiation on board, not on board, but there's a large amount of radiation on Mars. Because the atmosphere density is so thin, we can't, we're not being protected. So Earth is protected by our atmosphere. So we don't necessarily have that protection on Mars. So we need some form of protection in order to travel to Mars, because it's a 9-month journey to Mars. So we have to protect ourselves in the spacecraft as well as on the surface. One of the things that we're considering is, they haven't come up with any plans, keep in mind, but water is actually a good shielding mechanism. There's some ideas that maybe we can put our water stores around us to protect us from radiation. It's an amazing radiation protector. The suits they make are going to have better protection when they're outside the surface. They're also designing some type of habitats that are going to have radiation shielding, because the astronauts would spend most of their time in the habitats. But it's something that NASA's currently working on. They don't have an exact plan that I know of. One of the first steps was understanding exactly how much radiation the astronauts would be exposed to on the way to Mars and on the surface. And it is significant. And I think it's one of the major things they're going to have to deal with. So I think that's probably all that I have. Again, if you have questions, if you're watching this on a recording, Please submit your questions. If there's something that I can't answer, I'm always willing to go ask the people that know better than me, because again, I'm just a volunteer, so there's things I don't know, but feel free to ask me a question. And the radiation one is one that I know a lot of people have asked, but there is no exact answer to how they're going to protect. Oh, I did forget one other thing. They're also considering that it would be very difficult, but living in underground or inside some sort of structures may provide some shelter as well, but that would be very difficult, and I don't know how practical that is. So thinking of outside the box, all sorts of different answers for radiation, because that's a major barrier to traveling to Mars. So thank you for joining me. Let me know if there's other things you want me to talk about sometime in the future. So thanks for coming, and goodbye.